The objective of this video is to learn solubility rules and predict the solubility of a given ionic compound. By now you know what ionic compound is and what a covalent compound is. Ionic compounds, they contain a metal and a nonmetal. And then covalent compounds, they usually contain only nonmetals. Nonmetal combined with another nonmetal. For example, you can see things like sugar. Sugar is a covalent compound. You find only carbon, hydrogen, and oxygen. But on the other hand, things like salts, like table salt, sodium chloride, you can see the ions, the opposite charges tightly connecting. Now, when you consider a solid, you will find this kind of a rigid ionic lattice in ionic compounds. And if you put these ionic compounds into water, or even certain covalent compound or the molecular compound, if you try to put them in water, many of the ionic compounds dissolve, and if they dissolve, they all dissociate. Not all ionic compounds dissolve. There's a major number of ionic compounds that do not dissolve. So that is why I'm saying if the ionic compound is going to dissolve, it will also dissociate. So if ionic compound dissolves, it will dissociate. So what this dissolving and dissociation mean is that in the ionic compounds, once you put them into water, the ions will no longer stay like this, sticking to each other. They will try to separate. So that is what meant by dissociation. So if an ionic compound is going to dissolve, not only it dissolves, it also separates into the cation and anion. While in a covalent compound, you will not see these atoms separating. Now what you see over here is one molecule. Now you can consider this as one molecule of sugar. But what you have in this ionic compound, you have separate ions. The ions are going to separate into cations and anions in the water medium, while in the covalent compound that dissolves, they only dissolves. There is no dissociation. So ionic compound, they have dissolve and dissociation, while covalent compound, they only dissolve. There is no separation of these atoms. What only happens is that the molecules separate, meaning there will be water molecules in between the sugar molecules, but the molecule will not break down further. So in this lesson, we are going to look into certain guidelines that will help you to predict the solubility of a given ionic compound. Some ionic compounds, they will dissolve and dissociate, and then there are some ionic compounds that will not dissolve in water. Now in general, we call them as solubility rules, but I want you to consider them more like guidelines. The more you consider them as rules, the more you're going to find exceptions and things are going to get a bit harder. So as a general trend, all alkali metals, so that means group 1 elements, all of them. So when we study these solubility guidelines, it is easier if we categorize them into three general groups as always soluble, usually soluble, and not soluble. So what I'm going through at first in the beginning is this always soluble substances. So what is always soluble? All group 1 metals. So this is all of them. All the group 1 elements will be soluble. And then ammonium ion, NH4+. I mentioned that this is the only polyatomic cation that you find. If you find NH4 in a formula, that means that substance is soluble in water. And in general, large oxyanions, they are also soluble, always. For example, nitrate. Now, nitrate is a very commonly used polyatomic oxyanion in this course. So keep in mind, if you see nitrate, NO3-, that is always soluble. So, for example, if you find a substance like lithium nitrate, now you can say lithium nitrate is water soluble. Why? Lithium is group 1. If something is group 1, it is always water soluble. Nitrate, according to these guidelines, nitrates are always water soluble, so it is going to be soluble. Let's take another compound like aluminum nitrate. Now you don't find aluminum anywhere in this always soluble list. How do you know if this substance aluminum nitrate is soluble or not? Because of nitrate group. Here it has listed nitrate as an always soluble substance. So if nitrate is going to dissolve, the other one has to dissolve. So this substance, aluminum nitrate, is water soluble. Why? Thanks to nitrate. Nitrate being always water soluble. Alright. Now we are going to move on to the usually soluble substances. The halides. Halides mean the group 7 anions. You can see they are the anions, so the group 7. These anions are usually soluble. Remember, it says usually, not always. So that means there are few exceptions. What are the exceptions? Lead chloride and silver chloride. So that means if you have, lead halides and silver halide. So let's say if you're considering fluoride or chloride, bromide or iodide, if any of these ions sit with either lead or silver, they are going to be solids. They are not soluble. All the other halides except the halides of these two are soluble. For example, if you take aluminum chloride, let's take is this going to be soluble or not? Halides usually soluble. The only exceptions are lead and silver. Your cation is not lead or silver, so that means this is soluble. But if you take something like silver chloride, now this says that silver chloride is not soluble. Again, if you make lead chloride is not soluble because the only two exceptions for halides is lead and silver. So this is also not soluble. Sulfates. Sulfates are usually soluble except for these ones. So that means any sulfate is soluble except the sulfates made with these cations. Barium sulfate is not soluble. Calcium sulfate is not soluble. Lead sulfate is not soluble. And silver sulfate is not soluble. All the other sulfates are soluble. For example, if I write magnesium sulfate, is this soluble or not? This is soluble. Why? Magnesium is not in this list. So this one is soluble. How about barium sulfate? Now, if you go into periodic table, you will find magnesium and barium in the same group. So you can see for this, we cannot find a general trend like we stated here. So barium sulfate is going to be insoluble. Why? It is an exception, while magnesium sulfates are going to be soluble. And then we have this not soluble stuff. That means they are usually not soluble. So under this category, what you will often find is the polyatomic oxyanions like carbonates. Carbonates are usually not soluble. So if you make a carbonate of any compound, they are not soluble, but there will be exceptions. Look at this one. That means if you make a carbonate with group 1 metal, it will be soluble. If you make a carbonate with ammonium ion, it will be soluble. Those are the only exceptions. All the other carbonates are going to be insoluble. Another anion that is generally not soluble is phosphates, PO4 3-. Another anion is hydroxide. Now, how do you use this guideline? So these are usually not soluble. That means if I write a molecule like calcium hydroxide, this is not soluble. Why? Generally, all hydroxides are not soluble. But if I write as sodium hydroxide, now you might want to think, are there any overlapping guidelines? What about here? Under always soluble substances, you have sodium. Sodium is a group 1 element. If you have a group 1 element, no matter what your anion is, if you have a group 1 element, it's going to be always soluble. And because of that, this will be soluble. Let's take another example, something like magnesium phosphate. Is this soluble or not? This is not soluble. Why? Phosphates are usually not soluble. But if I write a compound like ammonium phosphate, is ammonium phosphate soluble? You might want to check the solubility rule. Are there any overriding ions? You can find ammonium ion under always soluble category. So that means if you find ammonium ion, no matter what your anion is, it's always going to be soluble. So this one is going to be soluble. So this is why I ask you to understand them as guidelines rather than rules. The more you try to memorize them as rules, the more complicated it is going to get, why you will have a whole set of exceptions and some overrides. Again, even calcium carbonate. If you take the carbonate, if let's say calcium carbonate is not soluble. Why? Carbonates are not usually soluble. This is not soluble. But if you take something like a group 1 metal carbonate, let's take lithium carbonate. Now this one is going to be soluble. Alright, this table summarizes what we learned so far in a different format. You can see that ammonium ion, and this table shows only few of the group 1, so you can add all of your group 1, all group 1 metals. They are all soluble. No matter what kind of anion you have, if you put ammonium ion or any of these group 1 metals, they will always be water soluble. And you can find how the others go. For example, you can see the silver. You can see that silver nitrate, chlorate, perchlorate, and this one is acetate. They are all soluble. But how about the halide? The chloride, bromide, iodide, sulfates, they are not soluble. Again, you can see all the insoluble substances. For example, if you have magnesium and hydroxide, you can see that magnesium hydroxide is insoluble. You can find silver perchlorate, it's soluble. Zinc carbonate, it's insoluble. So you can see that phosphates, carbonates, and hydroxide, these are the ones that most often used as anions: carbonate, phosphate, and sulfate. You can see sulfates are generally soluble. You have only few exceptions. But for hydroxide, carbonate, and phosphate, you can see that in general they are all insoluble, with just one exception over here for barium hydroxide. Alright, let's put what we learned into practice. You can pause this video and try to predict the solubility of these given ionic compounds based on the guidelines you have learned. Alright, the first one, sodium phosphate, soluble or not? Sodium is group 1. This is group 1. So that means this one is going to be soluble. Aluminum chloride. You can find that halides. Halides are usually soluble except lead and silver. What you have is aluminum, so this is soluble. Calcium carbonate. Carbonates fall here. Carbonates are not usually soluble, so this one is insoluble. Calcium chloride. Halides. Halides are usually soluble except these two, so this one is soluble. Magnesium hydroxide. Hydroxide comes under insoluble substances, so magnesium hydroxide is insoluble. Ammonium phosphate. Recall, ammonium ion. Ammonium ion is always soluble. Lead nitrate. We have nitrate. Nitrate is always soluble. Potassium sulfate. We have potassium, which is group 1. Group 1 stuff, always soluble. So that means if you have potassium sulfate and if you put it into water, it will separate as K plus and SO4 2 minus, and you are going to have 2 potassium ions for each molecule. Why? Because of the charge neutrality. This one, that will also dissolve and dissociate. You have Pb2 plus and then you will have 2 nitrates. So everything, all these ionic compounds that dissolve will always dissociate.